What's up, guys? It's your man Jimmy Chan here, and we're going to talk about functions and their graphs. All right, so we're going to start off with a point, and we're going to talk about that part. So typically, we call these an ordered pair. Right. Another thing to call it is a relation. The reason why it's called relation is because the x is actually known as your input. And we have more, obviously, inputs, but we also know that as our domain. And the y is our output, which is our range. Okay? So with that being said, you're going to have to know how to deal with finding the inputs and outputs, or the domain and ranges, three different ways. We could be given either a set of points, or we can be given a function. In other words, is either the function notation or an equation as we would know it. Okay? And the third possibility is with given a graph. Wow. Okay? So those are three ways we have to be able to determine the domain and range. All right? So, with that being said, let's start with the first example. Let's say that we are given a set of points. Let's say -7, 4, -9, 8, -5, -5, and 8, eight. Okay, so that would be a set of points. All right, so if we were looking for the domain, well, the domain is all possible x values. Okay, so in this case, if we look at these points, we have specific x values that we can name. And again, these are just 4 points on the graph. All right, so the domain would be -7, -9, -5, 8, right? With that being said, typically what I would like to do is to put these in numerical order. So I would start with -9, -7, -5, and 8. Okay? So that's what I would say would be my answer for the domain. Okay? With that being said, now let's talk about range. Okay? So if we talk about range, that'd be the all possible y values. Right? So in this case, if we look at their points, we have specific y values. Right? So our range would be 4, 8, -5, and 8. So two things here, right? When I rewrite the range here, number one, numerical order. That's right. And I don't have to write that 8 twice. It's already there. I just write it once, okay? So that would be my so-called range, okay? Now you're wondering why both of them are in squiggly lines or squiggly brackets, that's what I would call them. Now those is because I'm giving a set of y values and a set of x values. This happens to be a set of points, so that's why it's in those squiggly brackets, because the squiggly bracket actually means a set of, okay? All right, so with that being said, the next question that is going to be asked is the relation a function? Okay, so if I was to connect that to real life, right, inputs and outputs, so dirty dishes in the dishwasher, right, so the input is dirty dishes, the output should be clean dishes, which means that my dishwasher is functioning correctly, okay? But if I put dirty dishes in the dishwasher and dirty dishes come out, then my dishwasher isn't working right, is not functioning correctly, all right? If I put wet clothes in the dryer, my output should be dry clothes, right? But if I put wet clothes in the dryer and I still get wet clothes, then my dryer isn't functioning correctly, all right? So that's how I know if it's a function or not, all right? So let's see what the definition of function is, however. So function. It says every x, or input, corresponds to one and only one. Y, or output, okay? And you can think of input, output as domain and range as well, right? So you might see this as the equation define y as a function of x. Okay, so when you see that line, that means that is a function. All right, so as I was saying right just now, if I go in and I said, okay, if I input dirty dishes into my dishwasher and I come out with clean dishes, right? Then this is a function, right? However, I can't just name it off of one point, but that would be a function. However, let's say that I don't know how my dishwasher is acting. Sometimes it's working, sometimes it's not. So sometimes I put in dirty dishes, I get clean dishes. But sometimes when I put dirty dishes in, I also get dirty dishes. Okay? Or if I can just put it this way, actually, I put in dirty dishes. Some dishes are clean after the wash and some dishes are dirty after the wash. Right? So that tells me that the dishwasher is not functioning correctly. Okay? So, right? So that's one example. What's another example? Another example is what actually happened to me before, a while back, and that is that when I was at well, I wasn't there, but physically I was, just not attending school there. I was at Penn State University for an event, and we went to Ruby Tuesdays and we ate. And after I ate, went back to the hotel and I was curled up in a ball position there. So what I realized is that I had food poisoning. So what happens when you have food poisoning? Well, typically, right? I ate. Let's see here. Let's just say I eat dinner, and because I was curled up in that position, I felt really sick. I was sweating, right? And then I ended up going, oh, I gotta go to the bathroom. So I did a number two. But with that eating, same eat, okay, same dinner, I also got sick, right? So it's coming out of both ends, right? So with that being said, I was not functioning correctly. My body was not functioning correctly, okay? And this is called food poisoning, and I hope that nobody ever gets it, but sometimes it happens. But typically what happens is that if I eat, right, I typically would poop. So let's say that one night I went and got tacos, right? And I end up pooping, which makes sense, right? And next night I went and got steak. Well, what's my result? I also pooped, right? So my body's still functioning correctly, right? So next day I go for breakfast and I got some eggs, right? And I also pooped, right? So in this case, I'm still a function because my body still functioned correctly. Okay, I know it's kind of disgusting, but it kind of puts a real life situation into a picture of what would be a function and what would not be a function, right? So, but what do you notice between these things here? Now, don't forget that as we went, these are my x's, right? These are my inputs. While these are my outputs. Okay, so what do you notice about when it's not a function versus when it is a function? Keep on looking. Keep on looking. What do you notice? What you notice is that if, I hate when I do that, if the x repeats, right? Then the relation is not a function. Okay? So let's go back to the example that we were given, right? You come all the way back up here. That was the example that we were given. So let's go ahead and put that back down here. So if I was given those points again, so it was -7, 4, -9, 8, oops, -5, -5, and 8, 8. Was this a function? So you go, okay, let me look. Does any of the x repeat? And you're like, no, it does not repeat. So therefore, this is a function, right? All right, so let's say given -7, 4, -9, 8, -7, -5, and 8, 8. Bad. Yep, it takes practice. All right, so now you go, well, let's look at the x's. ooh, wait a minute, I saw this twice, right? The same thing twice. So therefore, this is not a function. Don't know why that occurs. It's as if my pen just started exploding. There we go. Right, so that's not a function because the x repeated. All right, so let's take a look at what about equations. If a equation is a function or not, okay? So what about equations? I'll put in here function or not. Okay, so let's take an example here. So example, so let's say I got x minus 8 equals y squared. Okay, so typically with equations, we're still very familiar, especially with this one, we're familiar with getting y by itself, right? So we have y equals mx plus b, right? But there's a y squared, so it's a little bit different, but I'm still gonna go ahead and solve for y. I'm gonna rearrange this so that it looks like what I'm used to, which will be y squared is equal to x minus 8, okay? With that being said, what would we typically do? You would typically take the square root of both sides, and every time you take the square root, you have to do plus and minus. So that means my y squared is equal to plus or minus the square root of x minus 8. Okay, so what we will want to do is just to kind of get you, if this is a function or not, this is what we're going to do. So number one, we got to remember that we have to, when this is given, our goal is to solve for y, all right? So from here, after we have done this, what I want to do is check. Not really check, but I also kind of give an example here, so I'm not going to call it checking, but I want to see if this is a function or not, okay? So I'm going to look at when x equals 17, okay? Let's take a look at that. And you're wondering how I picked 17 or why I picked 17. The reason why I picked 17 is because I was looking for a perfect square, right? So 17 minus 8 would be 9, and 9 is a perfect square. So that's why I chose 17, so that I don't have to deal with decimals and stuff like that. So let's look at that. So let's go ahead and take this equation. Oops, sorry. This would be just y. You're probably already asking that question. So if I say y is equal to plus or minus the square root of 17 minus 8, okay? So I solve. So y is equal to plus or minus square root of 9, which is y is equal to plus or minus 3. Well, what does y equals to plus or minus 3 mean, right? Y equals plus or minus 3 means y can be positive 3 and y can be negative 3, okay? So when I put in 1x, I actually get 2 y values, which means that I have 2 points here. I have when x is 17, I can get positive 3, and when x is 17, I can get negative 3, okay? So now we can look at this point, and these points, I should say, and say, are these functions? And you're going, well, the 17 repeated, so therefore it is not a function. So now you can say x minus 8 equals y squared is not a function, okay? And typically what you're going to see is because of the plus and minus, right? Because of the plus and minus, when you see that, you're already going to know it's not going to be a function, Okay, so I'm gonna put down here, look for plus and minus, okay? So now we know that is the biggest case, all right? All right, so now let's take a look at another example here, okay? Oops. Another example is, let's say x squared plus y squared, I'm sorry, y cubed equals 4, okay? So again, what do I want to do? I want to solve for y, okay? Okay, so let's go ahead and do that. So if that's the case, let me see, I gotta get y cubed by itself first. So I have y cubed. It's gonna equal to negative x squared plus 4, okay? So what do I usually do with y cubed? So y cubed is equal to negative x squared plus 4. So typically what I would do is take the cube root of both sides. Okay, so what happens with cube root? So in other words, now I have y is equal to the cube root, negative x plus 4, okay? There we go. All right. So now let's check it out. So I said, let's look at, I got the squared here, huh? So I was saying, let's look at 1. Okay, or actually, let me see. Yeah, let's just say it with 1. So let's take this and say, look at when x equals 1. Okay, so let's go ahead and do that. So we got y is equal to the cube root of negative 1, squared plus 4. So y is going to equal to the cube root of 1 squared is 1. So I'm going to have a negative 1 plus 4. So y is going to equal to the cube root of 3, right? So with that being said, did I get 2 answers? No, I only got 1 answer, right? No, because there's no plus and minus. Now cube root, you'll get a plus and minus because I can take the cube root of negative numbers, right? And get negative numbers. So when x was equal to 1, I get a cube root of 3. And that's the only answer I get. So in this case, since I only, each x, I only get 1 y, therefore this is a function. Let me write it properly. X squared plus y cubed equals 4 is a function. Okay, so there we go. All right, so what if we were given functions? Actually, we are still given functions. All right. So we're given equations here. So now I'm going to be given functions or evaluating functions. Let's talk about evaluating functions first. Okay. So the next thing we're going to talk about is evaluating. Okay. this you guys know as function notation. Okay, so if I was given y is equal to x squared plus 6x plus 2, okay, the function notation, the way you would do it is just everything else stays the same. The only difference is that the y gets replaced with f of x, okay? All right, so let's say I want you to find f of 2, right? And this would be what would be given here in the problem. So the question is, what's f of 2? Well, let me do it this way. Make that red, all right? So that means this is equal to 2 squared plus 6 times 2 plus 2, okay? So now I have 4 plus 12 plus 2, so therefore I have 18. So f of 2 would equal to 18. Okay? So the way we would say this in English is when x equals 2, y would equal to 18. Okay? And this is also a point, right? I said just x and y right there, so this is also a point 2 comma 18. Okay? So you kind of have to know all three of these facts, just so that when they ask you things just kind of make sense, right? All right, what if we went a little more difficult? Because you can use a number and throw it in there, no big deal. But what if we're asked for something like this? Find f of x plus 8, right? Well, we ask that. Well, conceptually, does it look different than f of 2? Yes, it does. But conceptually, it's exactly the same. And what do I mean by that? What I mean by that is, all I did up here was what? Replace the x with whatever's inside that parentheses, which is 2, right? So whatever x was, I replaced it with 2. So over here just says whatever x is, I would just replace with x plus 8. So again, I would go, okay, parentheses, squared plus 6 times this parentheses, x plus 8, and then finish it off with plus 2. Okay? Well, the downside of this is that I do have to FOIL or double distribute this, and this one I have to distribute. Wow. Okay, let's try this again. Okay? You almost can't see it. I don't like it because you can't see it. There we go. That looks better. Okay? So let's go ahead and FOIL that out. So I'm going to say equals to, and it's going to be x squared plus 8x plus 8x plus 64. Okay? Then I have plus 6x plus 48, and then plus 2. So I probably should make this red and make this blue. Okay, so this way you kind of know what I've done, right? So this part right here is blue, and this part right here will be the red. All right, so now what do? I need to combine like terms. So if I look, I go, I have 8x, 8x, 6x. And then if I look at the 64, I got 48 and the 2, and the x squared is by itself. So I'm going to have x squared. Let's see, I got 16 plus 6, which is 22x. 48 plus 2 is 50, plus 64 would be 114. Okay, so that means f of x plus 8 would equal to x squared plus 22x plus 114. And that would be my answer. Ooh. Undo, select, and get over here. Okay, so let's try this. Bring this down just a tad. All right, there we go. Come on. There we go. Okay, so that would be my answer right there. Not too shabby so far? All right. So what about if I asked you to find f of negative x? I'm like, well, it's the same, right? Same concept still, right? The looks of it is different because I've never seen negative x before. So you're like, okay, so you're telling me that what I need to do is put in negative x, negative x for wherever the x is, right? So negative x squared plus 6 times negative x plus 2. So that would give me x squared minus 6x plus 2. Okay, so f of negative x is equal to that. Voila, there you go. All right, so not too shabby, right? All right, how about with graphs? Let's look at graphs now, okay? So everything we've done so far, right? So what did we've done so far? We talked about domain, range, if it's a function or not, actually domain, range, if it's a function or not, and then also evaluating functions, right? So boom, boom, boom. So all three. So what we're gonna do is repeat everything, but with graphs, okay? Never seen that before. That's what it was. Okay, so we're going to repeat everything above but with graphs. Okay? All right, let's take a look. So the first thing I'm going to do is hit insert, hit this, hit function, and I'm going to do this right here. Okay, there we go. All right. So first of all, in this page, what I want you guys to notice is this. So over here, where 0, 0 is, we have a vertical line that goes through it and a horizontal line that goes through it, right? And typically there's arrows there, right? And we have an x-axis, and we also have the y. Oops. Axis, right? And then these 2 points right here is known as what? What do you think? What do you think? Both of these points are called the y-intercept. because it crosses the y-axis, right? All right, so what do I know about those 2 points? What I know about those 2 points is that the x is always equal to 0. So no matter where I plot a y-intercept, the x value is always equal to 0. Similarly, over here at this end, we have this point here, right? What does that mean? That means that this is a x-intercept. Right? So what do we know about the x-intercept? Well, no matter where you plot along the x-axis, the y is always equal to 0. Okay? So y-intercept, x is equal to 0, x-intercept, y is equal to 0. Okay? So that is important. All right, so now let's go ahead and go and insert another one of these puppies. Oops, insert file, sideways parabola. Boom, and there we go. All right, so what do we know? All right, so domain. Domain is all the possible x values, right? And x value only goes from left to right. So this is why I want you to think of it. So we have a sideways, it's called parabola, it's a sideways parabola. So let's pretend that the ceiling is dropping down and the floor is coming up to squish this parabola. So if we were to do that, it would look something like this. So as we squeeze and squeeze and squeeze, look at what happens, right? It keeps on going. And then notice where the arrows are. They're all pointing that direction. So what would I see here? That would be the question, right? So with that being said, if I did that, I will have a line that looks like this. Oops, wrong color. I wanted red. There we go. All right, that's what we will see if we were to squish it. All right, so let's go ahead and look at it again. If I look at this again, so again, if I squish it down, see where the arrow is, see where the butt of it is, right? So there we go. So when I'm here, that's what it should look like. All right. So with that being said, this is what I'm going to do. I'm going to write down the domain. All right. So draw red. So the domain. Now, these aren't going to be points anymore, right? The points are only given because we were given a set of points, right? So those are, like I said, 4 dots on the graph, where this is now a continuous line as we go, okay? So what does that mean? So the domain actually came from negative infinity, because it's always least to greatest, and it went all the way to right here, which is 5. So that would be my domain, all the possible x values. Now range is all the possible y values, right? And y value goes up and down. So that means the side of the walls starts coming in. So let's take a look. If I take this and start squishing this, what happens to my arrows? It'll start pointing upward, right? So right now it's like kind of sideways, but upwards, upward, 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 and then that will just point it directly above us. All right, so let's see here. Here we go. All right, so the range, what we're going to get is something along the lines of this. Okay, so let's take a look again. If I was to take this and squish it, right, it's going to start bending and bending and bending, going upward, right? All right, so what should we write for the range? Well, its arrows point up and down, so that means it started in negative infinity and it went to positive infinity. Okay, oops, the 5, sorry guys, the 5 actually is touching the 5, so therefore this is going to be a square bracket 5. There we go, okay, because it does touch 5. So that is if I was given a graph and I had to find the domain and range, right? All right, so after that, what do we end up doing? We gotta figure out if it's a function or not, right? Okay, so is a graph a function? Well, if we remember correctly, way up here, right? We notice what? That is not a function if the x repeats. Okay, so let's take 2 points where the x would repeat. Okay, so if we look at this graph, okay, so if you look at this, if 2 points were to repeat, that means I'm looking at, I don't know, 2 points that are here and here, right? So if I have to graph this, well, actually I wouldn't know that point. Let's pick something that we actually know the points of. How about that? That would make more sense, right? All right, so let's pick 2 points that we actually know the points of, which looks like right here and right here. So if I was to plot these 2 points, I'll have, or name these 2 points, it'd be -4, -3 versus -4, +3, right? So if I was to start listing points, what would happen, right? I would have 2 points that have the same x's. And if the x repeats, then therefore it's not a function, right? And what kind of line would these 2 points draw? That's right, it would be a vertical line. So with a graph, so again, let me repeat this. If x repeats, then not a function. Okay? So with this, we have something called the vertical line test. Okay? So in other words, if I took this graph again, so what I'm supposed to do, let's go ahead and use that color and just draw a line right here, okay? Let's try to make it vertical. All right, so if I was to do that, and if I'm moving this, I can move it anywhere in here and it's always gonna hit twice, right? It's gonna hit twice there, right? So therefore we know that this is not a function. Now some of you guys might say, well, what if I just selected out here? Then wouldn't touch a single point. Or what if better yet, I touch it right there. I only touch at 1 point. Would that make it a function? I'd be like, you're right. However, I'm gonna guess if you're curious, if your significant other is cheating on you, right? You heard it from the grapevine. Are you gonna check, are you going to check 0 sources and go, oh, nothing's happening, I'm good? Or are you going to only check 1 source and said that he's only messaging me and that's it, right? But what if I'm guessing that you're going to keep on looking until you find a point where, yes, he might be cheating on you, so you can confront him about this girl's name, right? So that's the reason why we kind of want to look at it that way, right? So in other words, this graph is not a function. Okay? All right. So with that being said, the next thing we have to be able to do is to evaluate. Right? Even with a given graph. So instead of what you will see is something like this. You might see them saying, well, we call this f of x. Okay? So let's say that they want you to find f of 4, right? Actually, f of 4, yeah, f of 4 is fine, right? So what would f of 4 be? And you got to remember, what does f of 4 really mean, right? F of 4 means, hey, I want you to find the y value when x is equal to 4, right? What's the y value when x is equal to 4? All right, so if I was to name all the possible points here, right? If I say, okay, I'm going to name, I don't know, this point right here, right? This point was -4, 3. This point right here is -4, comma, -3, right? So if I can name more, I would, but like if I name this right there, that'd be what? -11, 4. And this would be -11, -4. Okay. So again, I can name the points. So in this case, f of -11 would give you -4. F of, actually, yep. And this one up here will be f of -11 is equal to 4. F of -4 is equal to 3. And f of -4 can also equal to -3. Okay. So if I'm asking for f of 4, what we then want to do is basically take the line here and go to f of 4. In other words, the x value is 4. So there it goes. So essentially what I'm looking for is these 2 points right here, this point and this point. Well, if I look at that point, what do I get, right? I get, so this could either equal to 1 or -1, right? Both of them are going to happen. So in other words, I have, so f of 4 can be plus or minus 1, right? Now we're kind of working backwards to it, which means I have 2 points. I have 4 comma 1 and 4 comma -1. Ooh, 4 comma -1, okay? So look at what that says. Whoa, where'd it go? There it is. All right, what does that mean? That means, you're right, not a function. Okay, so that even shows it's not a function because they're x repeated. All right. All right. And if I said, oops. In the next example, let's say I say, what's f of -11? And you would say, plus or minus 4. Is that right? Yep. So that means, again, I have plus and minus 4. So that means at -11, I get +4. And at -11, I get -4. Okay? So that's what it means. So again, it's still, again, not a function. All right. One more. Nope, that's it. And this is all she wrote. So again, today what we talked about was domain and range, right? We also talk about evaluating functions. So with given sets of points, function, and the graph. So that's exactly what we did. So we found the domain and range, and we found if it's a function or not, and then we also evaluated. All right. I hope this helps. If there's any questions,